garbage truck is not a transport vehicle, it is a mobile compaction factory, and it is quietly one of the most dangerous machines operating in any city every single day. Most people assume these trucks just haul trash to a landfill, but the actual job is volume reduction. The key number is 4-to-1. By the time a load is delivered, every cubic meter of space inside that body holds what used to be 4 cubic meters of loose waste. Cardboard, plastic, metal, crushed into a single dense brick. That ratio is what makes the economics of waste collection viable. Without it, cities would need 4 times as many trucks on the road, 4 times the fuel, 4 times the cost. Everything about the design of these machines comes back to that number. It starts with the engine, but a garbage truck engine has 2 jobs running at the same time, and that is what makes it fundamentally different from any other truck on the road. The first job is moving the vehicle. The second is powering the hydraulic system that drives the compactor. Both are continuous. Neither stops. The connection between those 2 jobs is called the power takeoff, or PTO. It is a mechanical link that splits torque away from the drivetrain and feeds it directly to a high-flow hydraulic pump. The moment the driver activates the compactor at a stop, the engine RPM automatically climbs. The electronics do this on purpose. The pump needs a minimum flow rate to maintain pressure, and if the engine slows down, the whole system loses force. That pump pushes oil through control valves and into cylinders at pressures between 170 and 190 bar. The compactor blade, the bin lifter, the tailgate locks, the ejector panel at the front, all of it runs on that pressurized fluid. Lose the pressure, and the truck is dead weight. Here is what actually happens when you hear that mechanical crunch from the back of the truck. Waste falls into the hopper at the rear. A heavy compaction blade sweeps inward, pulling the load down and back. Then a hydraulic ram drives it forward against the retention wall, forcing it into the main body. The blade retracts, the cycle repeats. Start to finish, that takes about 20 to 35 seconds depending on what is in the load. What most people do not know is that compression is happening from both directions at once. Inside the body, at the front, is the ejector panel, a full-width movable wall. Modern systems use a back pressure valve that keeps that panel under constant resistance as new waste is pushed in from the rear. So the load is being squeezed from the back and resisted at the front simultaneously. That 2-directional pressure is what pushes compaction ratios to 4 or even 5-to-1 on commercial loads. The load builds in layers, dense, interlocked, and nearly solid by the time the body is full. Engineers design every centimeter of that internal volume to be used, because on a garbage truck, efficiency is not measured in kilometers per hour. It is measured in how much compacted mass fits in one run. If this kind of engineering is your thing, subscribe, more of it coming. While all of that compression is happening, something else is going on inside the body that nobody talks about. When organic waste is crushed under tons of force, it releases liquid. That liquid is called leachate, and it is one of the most chemically aggressive substances a working truck deals with every shift. It is a mixture of water, organic acids, heavy metals, and decomposition byproducts. Ordinary steel exposed to it continuously can corrode through in a matter of months. That is why the interior of the body is either coated with specialized epoxy or built from wear-resistant alloy steel. The floor has drainage channels that collect the leachate by gravity and direct it into a sealed tank under the chassis, typically between 200 and 400 liters of capacity. The tailgate is sealed with high-density rubber profiles and held shut during transit by hydraulic tension clamps, pulling it against the frame with tons of clamping force. If that seal fails and leachate drips onto the road, it is not just a hygiene problem. It is an environmental violation with serious legal consequences. But chemical corrosion is not the biggest threat inside a garbage truck. That title goes to something people throw away without thinking twice. Lithium-ion batteries end up in regular trash constantly. Phone batteries, vape pens, power tools, laptop cells, and the moment a compactor blade contacts one of them under pressure, It can trigger thermal runaway, a self-sustaining chemical reaction that generates extreme heat without needing oxygen or an open flame. The crushing itself is enough to start it. Inside a body packed with paper and plastic, that is all it takes. In January 2025 in Boise, Idaho, a single vape pen in a load triggered a fire mid-route. The crew had to dump the entire load on the street to stop the truck from burning. In Southern Oregon, in August 2024, a recycling truck was completely destroyed. These are not rare events. Fire departments across the country report them regularly, and the frequency is increasing year on year as more lithium-powered devices flow into the waste stream. The compactor cannot detect it. The cycle does not pause. There is no warning. Beyond fire, the compactor itself is one of the most mechanically dangerous systems operating in a public space. The hydraulic force it applies is constant and indifferent. A cardboard box and a human arm get the same pressure. Modern trucks are built around multiple layers of protection. Emergency stop buttons sit on both sides of the loading zone, within reach of workers on the ground. The compactor requires continuous operator input. Release the control and the cycle halts immediately. Newer models add ultrasonic sensors and light curtains. The moment a person crosses into the hazard zone while the blade is in motion, the hydraulic circuit locks almost instantly. These systems work, but most serious accidents in this industry still trace back to one thing: human error at the point of loading. Once the body is full, the truck drives to the landfill. And here is something most people have never considered. Why does a garbage truck not unload like a dump truck by simply tilting the body? The answer is the load itself. Compacted waste is not loose material that slides out. It is a dense, irregular, solid block. And the weight distribution of a full body is too unstable to tilt safely on the rough, uneven surface of a landfill. A 30-ton machine with that center of gravity tilting on soft ground is a rollover risk. So instead, the ejector panel does the work. That movable front wall is connected to a multi-stage telescopic hydraulic cylinder. The tailgate opens, and the cylinder extends from one end of the body to the other, pushing the entire compacted block out in one clean motion. Like the plunger of a syringe, all four wheels stay on the ground. The truck never tilts. The load exits as a unit. The basic engineering is the same across types, but the configuration varies significantly by region. In the United States and Australia, the automated side loader dominates. One driver, a joystick, a robotic arm that grabs standardized bins and empties them without anyone leaving the cab. Fast, safe, and low on labor cost, but it depends on uniform infrastructure, standardized containers, wide streets, clear access. If a car is blocking the bin, the arm cannot reach it. In Europe and high-density cities, rear loaders are more common. They need workers on the ground, but handle narrow streets, irregular containers, and unpredictable conditions far better. Cost, regardless of type, is significant. A new automated side loader in 2025 runs between $280,000 and $378,000. Fuel consumption in urban stop-and-go operation lands around 45 to 60 liters per 100 kilometers, sometimes more, because the engine is never just driving. It is running the PTO and the compactor on every single stop. Brakes, suspension, and hydraulics wear faster on these trucks than on almost anything else in the fleet. The reinforced frames, shortened gear ratios, and sealed hydraulic lines are not over-engineering. They are the minimum required to survive the daily operating cycle.